Hello students. I'm going to try out a little bit of a video introduction to the chapters of the book that you're assigned to read, chapters 1 through 3. This is not going to serve as a replacement for reading those chapters. I just thought I'd try out providing a little bit of a guideline for what to look for in the chapters. Chapter 1 is largely introductory stuff, commentary, things of that nature. Probably the key thing that you might remember from chapter 1 is the idea of the wrong information. Much of what this class is about is how science works, and you've learned a lot of facts about science in your classes in grade school or high school. Even if they were lousy classes, you probably still learned basic facts from science, but you were provided with no explanation for how we know those facts. How do we know the things we know? That's very much a focus of what this astronomy class is about. Yes, we're going to learn information about the universe, but we're also going to learn how do we know the stuff that we know. A lot of what's involved in understanding not just what we know, but how we know what we know it's tied up with how we got things wrong. A big part of how we know what we know is that, well, we used to think this, and we had pretty good reason for thinking that, but it turned out to be wrong, and here's why. And then what did we do next to try to get the idea right, and then what was wrong with that idea, and so on and so forth, till we finally get to what our present idea is, and our present ideas, we hope that they are right. Some of them we're more confident about being right than others, and we're going to learn about that over the course of the class. One of the things from the first chapter is that we're going to sort of forget everything that we know and go only with what we can see and start from there. Build from what we see with our eyes up to the understanding that we have of the universe today. What we see with our eyes gets us into chapter 2. A large part of chapter 2 is discussing what you would actually see if you went out and watched the sky, which you can do. You want to check this stuff out? Go out and spend some time looking at the actual sky. It'll take some time to do it, but you'll confirm what's in the book, and you can see it for yourselves. Science is not about what's in books. Science is about the real world, looking at the real world, making observations about the real world, trying to confirm our ideas about the real world by comparing what our ideas say against what we actually see out there. So the first thing that this chapter talks about is if you went to a place with a nice, clear, flat horizon down by the equator. The reason I choose the equator is because this is where everything happens in the most simple fashion. If you're looking out over the ocean, you have a nice, simple horizon. The way things rise and set at the equator is very straightforward. Everything that we're talking about would apply here in Kentucky as well. It's just a little bit more complicated. So basic things you would observe, and you can go observe this yourself if you want. The sun sets in the west. The moon sets in the west. The stars set in the west. They all rise in the east. So everything rises in the east and sets in the west. If you look at how much time passes between one sunset and the next sunset, if you were to get it into your head to test this out, by timing it with a watch, you would find that from sunset to sunset is about 24 hours on the equator, right at 24 hours. In Kentucky, there'll be a little fluctuation, and even more if the horizon's not flat. But on average, 24 hours. Time from moonset to moonset. You watch the moon go down. Watch the moon go down another time. It's longer. It's 24 hours, 48 minutes. And then stars, if you watch a star go down, and then you time how long until the next night, it also sets, it's a little bit less than 24 hours. It's 23 hours and 56 minutes. So what we see is everything, if I'm sitting here looking to the west, watching the sun go down, all right, I see the sun rises behind me, sets in front of me, and to go from setting to setting again, 24 hours. Stars, to go from watch a star set to watching it set again, 23 hours, 56 minutes. Okay, that means that if I imagine those two things, the sun going around and the stars going around, the stars are gaining on the sun. Okay, the stars go around a little bit quicker than the sun does, which means that any given star that I observe will eventually catch up to the sun in the sky, and of course the sun's so much brighter we won't be able to see it, which means that we won't be able to see the star. So that means that the stars that we see will change over time. Well, it turns out that at 4 minutes every day, if you do the math, it comes out to the fact that the stars will cycle around past the sun completely in 365 days, a year. So a year is actually defined, it is what the cycle of the stars are. Here in Kentucky, we think of a year as being from one winter to the next, or one summer to the next. So there's parts of the world where you don't have the seasons like we have. But you still have that cycle of stars. So anywhere on Earth, you're going to have that cycle of the stars that defines what a year is. The moon, at 24 hours, 48 minutes, is falling behind the sun in the sky. Okay, so the sun goes around every 24 hours. The moon, rises in the east, sets in the west, every 24 hours, 48 minutes. So that means it's losing ground against the sun every day. Well, you figure out that 48 minutes, how long does it take before the sun essentially laps it in the sky? That comes out to a month, about 30 days. While the moon is doing that, the moon goes through a cycle of phases, from crescent to quarter to full, back to quarter, back to crescent, to a new moon. And so that cycle of the moon defines a month. So within this, we have the basic things for why people would ever start studying astronomy in the first place. Astronomy being the oldest of sciences. Astronomy defines direction, east and west, and of course then north and south. And then astronomy, it can be used to keep time. Days is the rising and setting of the sun. Months is the cycle of the moon. Years is the cycle of the stars. So pretty much in any culture, there's going to be a study of astronomy at some level, even if it's just keeping track of the stars or the sun or the moon. Interestingly enough, in a lot of cultures throughout history, people probably, even though they don't know much about the universe as we know today, they probably know more about the sky than the average person knows today, because the average person doesn't spend a whole bunch of time out under complete darkness seeing the stars and the sun and the moon. We don't need to look at the stars, the sun, and the moon to keep track of time. We have electronic devices, calendars, and so forth to do that. Chapter 3, very short chapter, focuses on one particular thing, and that is that the heavens don't change, at least as we see them on a human scale. The stars in the heavens that you see on any given night are the same stars that your grandparents saw when they were kids, the same stars that were around during the American Revolution, the same stars that were around at the time of the pharaohs. Any time, any given night. I'm recording this in August. Okay, August the 18th, actually. No, 19th. Sorry. August 19th of the year 1950. You see the same stars as you would see tonight. August 19th of the year 1800. Same stars. August 19th of the year 500, same stars. Okay, so the stars don't change. The cycle of the moon doesn't change. The cycle of the sun doesn't change. It didn't used to take, days didn't used to be 36 hours long, 24 hours. And this will play an important role in our further discussions, is that the heavens are one of the most unchanging things that humans experience. And you may have heard in science classes and so on and so forth that the stars are born and stars die and things of that nature. That's getting a bit ahead of where we are in class at the moment. Suffice it to say that when you look up at the stars, they look the same as they did 500 years ago. That there are not, we have old maps of the stars, and from that time, and there are not stars visible now that were not visible then, and you won't go find a map of the stars back then that show stars that have since gone away. Okay, that from a human experience, the average person's experience, looking up at the sky, the stars don't change. New ones don't appear, old ones don't go away. I hope that it provides you a little bit of guidance for what you're looking at when you're reading through chapters 1, 2, and 3.